suppose that you have a current source which is pumping out charges at a certain rate, and those charges run through a circuit and then they get to a fork in the road. And suppose that there's 3 different paths that the charges could take in order to make their way back into the current source. So what we have here is a thing called a current divider. So let me just make a note about that. So this is a current divider. So this occurs when you have resistors in parallel. Basically, the current is split off down these 3 separate paths. So it's divided up down these 3 separate paths. And we know from Kirchhoff's current law that the current flowing in to the node being this region at the top here, the current flowing in must equal the current flowing out. So we know the total amount of charge, but what proportion is split down each of these branches? Well, that's what we use the current divider equation in order to solve. So I'm going to write down what that is. Basically, if we have current flowing in, I'm going to call this I in for the current in, and then the current that I would like to solve is the current in one of my branches. So I'm going to call this I branch here for the current in this particular branch. And suppose that there's a resistance of R branch here on this particular branch that I'm trying to analyze. So the result, or the equation for a current divider, is this. It says that I branch, or the current in a particular branch, is equal to the input current multiplied by this ratio, which is R total divided by R branch. Okay, so it's kind of the opposite way around to the voltage divider formula. So don't mix those things up. In this case, it is the resistance across the component we're looking at, which is on the denominator of that equation. So this one is, again, really important equation that you need to recognize, and you need to know this and be able to just write this one down. There's a proof in the textbook if you want to see where this actually comes from. So basically what we would do is calculate R total for the resistors that we have. So if this was R1 and R2 and R branch over here, then we find R total to be all of the resistors in parallel, and then we can use this equation to produce our current divider. So let's do an example. So this one comes from the textbook, example 3.7, and they give this particular circuit here, and they ask us to calculate the current I0, which is labeled over here on the right-hand side of this circuit diagram. So in order to do this, we need to first calculate what is the total resistance of this entire circuit. So I'm going to write down what is the total resistance. And so on this first branch, just looking over here at the moment, I've got 2 resistors in series. And so I remember that when I have resistors in series, that I add their resistances together. So this one is 36 plus 44 ohms. Now that is in parallel with this 10 ohm resistor over here. And so I will write that this is in parallel with 10 ohms. So I use the kind of 2 bars to indicate this concept of being in parallel with. Looking at my next branch, that's 40 plus 10 plus 30, because these ones are in series, and that's also in parallel with 24. So I can now go through and simplify this. So in particular, I have 36 plus 44 is going to be 80 ohms. So 80 in parallel with 10, in parallel with 80, in parallel with 24. Then I can write down what will be the total resistance, kind of resolve this parallel operator. So remember, we take reciprocal of each of these. So 1 over 80 plus 1 over 10 plus 1 over 80 plus 1 over 24, and that whole thing to the power of minus 1. So you get out your calculator, you type all of those in, and the answer that you get is 6 ohms. So the total resistance of this network is 6 ohms. Notice, by the way, that this number here, this 6 ohms, is pretty small in comparison to all of the numbers that you see here at the top. So when we have many branches in parallel, the resistances can get actually quite a bit smaller than the input resistors that go into that network. So now that I know my total resistance, I can go and use my current divider formula. So that is that I0, the current that I'm interested in, is the input current, which here is 8 amps. So it will be 8 amps multiplied by the total resistance, so R total divided by R branch, the branch that I'm solving. So that's 8 times R total was 6, and R branch, looking up at my circuit diagram, I can read off the value 24 ohms over there, so I put 24. So this is 48 over 24, which is 2 amps. So the current in this branch will be 2 amps. So that's how we use a current divider to analyze a circuit when we have multiple branches in parallel and our current kind of gets split up along these branches. Then we can write down a simple equation to calculate how much current will be in each of those branches.